Hi, this is Rick. I recently had the question, if we expose a comic book to light and peroxide, maybe sense that the paper is stiffer, possibly more weak, how much stiffer is it, and how do we quantify that, and how much weaker is the paper? So I decided to make a test tool to help understand that, or at least track it, at least the first draft. This is my first draft of that test tool. And also, the other question was, how much light can we add without peroxide? How long does it take, and what are the effects on the paper if we do that? So this video is not intended to answer those questions. So as a quick intro, this is what a test tool I made. I'll show you another video in a moment. I just took a strip of paper, and I have a section for a burst disc for first testing here. Spoiler alert, that didn't work well initially, but the second test will work. This was not a good design. It's a little bit better. And then this is my stiffness testing area, which I don't know if it's good or not. I just essentially what I'm doing is just measuring how far out this paper will hang before it sags. It ends up at this joint right here. Remains untreated here, even though it's treated there, so there's limited effectiveness. It does work. It does show something, but it's a minor difference. I need a better way to measure how stiff that is. And then the other question, light without peroxide. This is an example. This was 9 hours. So I did this after the initial test. It's not a big difference. Right? So these are interior pages. Actually, I'm not showing it well. It shows it much better to the naked eye. But this is the same book. That's an interior page. This is 9 hours exposure to light with peroxide. And this is the original condition of this page. So it doesn't look a lot better, but it's a little better. So it's not nothing. So anyway, here's a test fixture with an interior page. I did some interior and exterior pages, and they hang at different distances. The interior pages hang about 1/8 of an inch away from the edge. As you'll see, what I'll do is I'll measure this here. See, and this is an interior page as well. It's about 1/8 of an inch away from the edge to the paper sags, away from the mandrel. So it's not very far. It's pretty floppy. And next, I'll show you the burst disc holder. So I made this little half spherical 1-inch ball on a scale, and I took a high-speed camera. I mean, I could have just plugged this into Excel or something, but I wanted to see if I could capture. They were all between about 610 and about 670 grams of burst strength. You'll see the bursting here in just a second. This needs to be improved because in several of the tests, the paper slipped or moved before it burst, which gave me a dramatically different weight. So I need to work on this test a little more, and it's not included in the results of this particular study. So here are our factor conditions. We have peroxide in 435 light, 435 light only. We have peroxide in 455 light, 455 light only, and just peroxide. So here, these are the cover conditions. Those are the interior conditions are the same. Here's a picture of the initial conditions for the left side box, and this is the 455, which is the right side of the box. And there's cover parts and interior pages. Here is an image of the difference between. This is similar to the page I showed at the beginning of this video, where I treated an interior page of a comic book to 435 nanometers of light for 9 hours, a long time. I did whiten it and lightened it about this much, so you can see the comparison here. This is an interior page. You can see exposed to light and peroxide. There's a subtle difference in how stiff the interior pages are. It's not a lot, maybe 1/8 of an inch, but the exterior pages, there's a bigger difference. You can see the cover. The cover is visibly stiffer than the cover that was not exposed to peroxide and light here. And on the peroxide only, there was no difference at all. Interior or cover, there was no difference in the stiffness whatsoever after exposure to 3% peroxide. So what do we have for results? Well, really not much change. These differences are changed from inches to centimeters in stiffness. I didn't measure the burst strength because I had some problems with it, but if you look at just the interior, there's almost no difference in stiffness under any condition, but 435 and 455 were the same. It was just a little little bit of stiffness but only with 3% peroxide in both frequencies. But on the covers, there was a little bigger difference. The 435 and 450 are probably an error. I imagine if I did this 10 times, these would be the same color, but they were quite a bit stiffer than the interior pages. So I guess the summary is that the covers seem to stiffen more than the interior pages, and it takes both peroxide and light to induce that stiffness as measured in this particular meter. And with respect to whitening at both frequencies, you can see that the covers whitened about the same. There wasn't much of a difference there. Anyway, that's it. It's not much of an experiment, not really exciting data. I'll make improvements in the future. I'm looking for ideas from people like you without buying expensive instruments, which, yes, I know they exist. I've used them lots of times. Just trying to get something in the hands of people that they can use themselves at home to do similar tests for themselves and contribute to our general knowledge without a lot of cost. So anyway, I hope you enjoyed the video. Take care. See you later. Bye-bye.